Okay, a vertical line test. It's a test to see if a relation is a function. So if you're asked, is this relation a function, and you have a graph, you could use this thing called a vertical line test. And it's really just comes directly from the definition of a function. It's just looking at it slightly differently. So it says if there is a vertical line that intersects the graph of a relation in two or more points, then the relation is not a function. Okay? If there's a vertical line that intersects the graph of the relation in two or more points, then the relation is not a function. If each vertical line intersects the graph of a relation in 0 or 1 point, then the relation is a function. So there's no vertical line that intersects it in two or more points is what that's saying. So that's really just from the definition of a function, right? A function, each first coordinate corresponds to exactly one second coordinate. That's the 1 point. The 0, it just comes from when you don't have anything in the domain of the function or relation. So this value of x, which I've called x naught, that's N-A-U-G-H-T, it's another word for 0. It's just what we use for subscript 0. Right. This value of x is paired with more than one value of y. I didn't mark the notches so you can't tell what they are, but there's one here and there's one up here. So this is not a function. It fails the vertical line test. You can also look at it this way. If it's a vertical line, if it intersects the graph in 1 or 2 points, then it is a function. If it intersects the graph in 2 or more points, 1, 2, it's not a function. So this one's not a function. Right? So it's because x naught is split into two different numbers by this relation to y1 and y2. So that one's not a function. This one is a function. No value of x is paired with more than one value of y. That's directly from the definition. Vertical line test, you just check every vertical line. I just drew a few just to represent that you're checking all of them. And if none of them intersect it twice, it's a function. If none of them intersect the graph twice, it's a function. Okay. This graph does not represent a function. This relation is not a function because this particular vertical line intersects it twice. So it's not a function. I can make it into a function, though, by removing one of the 2 points, which is what I did here, because now the vertical line that would intersect there twice, it goes through that little hole and misses the horizontal one. Okay, so that's the end of that one.